Okay, welcome to this webinar hosted by the Reuse Company. A few rules before or guidelines, I should say, before we start. You will be muted during the webinar. Please write your comments or questions in the chat function, and I will answer those at the end of this session. And the webinar will be recorded, and you will be provided with links to the recording and also this material after this webinar. This webinar is called Boosting COSYSMO to Derive a Comprehensive Acquisition Benchmarking Tool. So we will be focusing on acquisition as a process. First, a few words about Reuse for those who don't know us. The Reuse Company is a solution provider specializing in the application of a semantic technology and artificial intelligence to improve the digitalization of the system engineering lifecycle. And if you know the processes like ISO 15288, acquisition and supplier are two processes within systems engineering. So those are the ones we are focusing on right now. We at the Reuse Company were very proud of the System Engineering Studio Suite, which includes a lot of different capabilities. Amongst the famous requirement quality analyzer, the RAT, the authoring tool, the knowledge manager, traceability studio, verification and validation, decision management, which is the artificial intelligence platform, and also interoperability between different tools. And we will be focusing on this one, the new one, which is focusing on a few aspects on handling data for acquisition of complex technical systems. Our customers are primarily within those industries that do work with complex technical systems like aerospace, defense, automotive, energy, healthcare, infrastructure, but also industries or organizations working with legal aspects and software. The main office is situated in Madrid, in Spain. I'm sitting in the Scandinavian office in Stockholm. We also have an office in the United States, and we have partners in Belgium and in Japan. And me as a speaker, my name is Fröling, as I said. I'm working from Stockholm, and I'm experienced in systems engineering and requirements engineering. And I am focusing right now on acquisition. Meaning that I've been working a lot with those aspects the last couple of years. The agenda for today is actually to reproduce a presentation I did in COSY at the COSY International Symposium this year, which was held in Canada. So therefore, you will recognize the COSY logo and as such. So the background is, as I said, to look more into the acquisition context. I will talk a little bit about the challenges with public procurement. I will give you a very, very brief introduction of the COSYSMO as a data model and how we can use the COSYSMO model for acquisition, because it's not meant to be used for acquisition as such. Looking into the different aspects regarding COSYSMO model and how you could use our tools, for instance, to look into requirements. How we are dealing with risk as part of COSYSMO, and how we foresee how you could use Technology Readiness Levels, TRLs, or CMMI's capability maturity model as inputs to the COSYSMO model. Then, of course, if we want to do, I would say, proper acquisition, we are interested in cost. And if you want to have a balanced procurement, you are for sure looking into not only the price of the product or the system, but also the life cycle cost aspects. So you can value technical performance quality against the total cost of ownership, the TCO. I will give you a very brief example on what we have been doing in a small project, and some key takeaways and observations, I would say, from my part. So what is this? This is a rather complex picture, but as an idea, we have a system we are interested in procuring. Okay, for instance, a military ambulance. That ambulance for sure has its own life cycle, and if we assume that life cycle are following the famous V model, which you have in gray in the background, the goal itself is for sure that we are interested in procuring a system which has a low cost of ownership, but at the same time we're interested in high availability, meaning that we have to balance things in order for us to get a good product or system at the end of the day. And if we have the opportunity of being in the role of a purchaser, we need to manage a lot of different balls here, because we have to figure out what is the user needs, what is the capability gap that they are interested in us helping them with, and we need to manage the contractor and the relationship between the contractor. Perhaps first in a request for information, then for sure we're interested in doing a proper procurement with request for quotation, and we need to do a lot of things. So we need to have an idea on how to manage these aspects of costs and weigh that against the need which is needed in the first place. So that was the idea when we saw the COSYSMO model, that we actually can use that in a way to gain more information. Because the goal for every acquisition is to balance out cost, technology or quality, and the risk. So we need to find a balance. And the balance is also set if you look into the different aspects of a procurement project. I usually tend to say that they are threefold. You have the business aspects, which are all the aspects around procurement and following the procurement laws. Then we, of course, need to describe the system we're interested in procuring. And then we have to manage the aspects of how is this project going to be realized, so we get a delivery of a good systems at the end of the day. So we need to have a balanced set of requirements, and we have to have a balanced way of working as well. Because at the end of the day, we are not interested in spoiling funds and losing taxpayers' money just because we have a faulty process. So the background for us is that we need to have a structured way of working. Otherwise, we just provide data and somebody asks or somebody replies that, yeah, we will fulfill that and it will cost X amount of dollars or euros. It needs to be evidence-based, okay? So we need to be able to prove why we have chosen a specific provider of the quotation in order to say that, oh, is this the best one? And the idea when we saw the COSYSMO model is that we should be able to use it for estimating cost and risk and the balance I've been talking about. And when we examined the COSYSMO model as such, we saw that there are good correlation with other methods like technology readiness levels. How immature is the product itself, which is offered by the bidder? And also how mature or immature is the organization providing that quotation, that organization which we hopefully will sign a contract with. And also what we saw when we looked into the COSYSMO model can we use the INCOSA guide to write requirements and their views on what is a correct requirement and what is a complete and consistent set of requirements in order for us to have a more efficient and a method which is evidence-based, and it's also repetitive. So we don't have to invent the wheel every time. That's that. And if you then combine it with the need from the procurement side, the legal aspects, there are multiple steps which need to be done when you receive an offer until you have you're ready to sign a contract with somebody. And those aspects of technical performance evaluation are set up with some built-in flaws, I would say, because it's very easy to get a subjective process where people just, if you don't guide how the bidders are responding to your request for quotation, they will reply in any shape and form, and it will be hard to evaluate one bid if it's actually true or not, but also to compare the different bids with each other at the end of the day. Because even if you are not supposed to look into the different bids as such, at the end of the day, you need to say that this one is better than this one. So we should have a process that fits this, and that was the idea when we invented or we developed this acquisition studio capability. It's a very structured way of managing data through these steps, through this process, and also to build a solid foundation of the contracting requirements for later design development, verification, and validation. And I think I've been talking a little bit about the different challenges that we see in these processes. One of them is that you actually have a built-in tension in the process itself. Sorry, and that's the technical people. They want to write requirements so that they get the piece of equipment, the system that they want. And they don't that much care about the funding and the cost. The cost people, the procurement people, the economic functions, they are interested in the costing side. So you have a tension here that many times draw the focus from the technology to the cost itself. Oh, this costs too much. We need to reduce something. Okay. Then, of course, as I said, the process tends to be rather subjective because you have not control of the data you get in. So you need to read it in the shape and form you have it, and you need to set some kind of score or some kind of idea on this is better than this one, and it's not controlled. And there are very strict laws and regulations when it comes to treat parties equally, be transparent, don't be you shouldn't judge people just on the different shapes and forms they have on their material. You should look into the information itself. But if you not control the process, it will be inherently hard to evaluate. It will be hard to look into. And when you take that also into account that the subject matter experts, they have a lack of time, and they have a disadvantage that well, price will always win over quality. That's a typical thing we usually say. So we need to help them in evaluating and having a process where they can say that this is the quality we need, and this is the best mix of quality towards the cost we are prepared to take. And if we don't have a controlled process and we don't help people in writing the good requirements and the requirements which are needed, people tend to cut and paste, and they tend to reuse requirements and not reuse information, meaning that they will probably write requirements on the same thing they had before. 10 years ago we did this procurement, and we can reuse requirements, but that tends to limit the innovation, and it becomes constraints actually, which are imposed very early in this process, limiting the possibility for the bidders to come up with new bright ideas on solving an existing problem. So of course, our tools like the requirements quality analyzer and the requirements authoring tool will help in this process in writing good requirements in the specification themselves. Because at the end of the day, perhaps you don't do this every day. So you lack information, you lack knowledge, and how can we expect that we prepare good quotation material or bidding material if we don't do it that often. So back to the COSYSMO model then. When we start to look into this COSYSMO model, and this was part of a small pilot project we did with a customer in Norway, was that we saw that there are two major things as input to this algorithm. One is called the size drivers. And we saw that the requirements, the number of interfaces, the usage scenarios, the complexity in functions and software, and some other factors. If we did a good system engineering work, when we set up specifications and the material that was supposed to be sent out to the bidders, we actually had a fair good idea of this ourselves. So this is something that we did as a procurement organization. While the effort multipliers is a lot connected to the supplier and the supplier's different skill sets and how good they are at predicting things. So we actually used different aspects of what you can see the CMMI. I will show you this in a short while, that we could use that as an input. But when it comes to our requirements, we already used the requirement quality analyzer from the reuse company with a set of metrics from COSYS. We could start to measure the quality of our requirements and use those as input to the model. And when it came to the application side, we need to figure out how mature is the solution provided by the bidder. So we thought that, well, we have a strong connection between those application factors and technology readiness levels. They were talking about the same thing. So let's see what the bidders are saying about their current proposed solution. And the same, as I said, with the CMMI metric, capability maturity model. How mature are your bidding organization to perform different system engineering tasks which were at hand? And we used the aspects from EIA 632 process, which talked about the methods within systems engineering. You will see that in a short while. And even though we noticed that the focus of either systems engineering and 15288 as a process and the COSYSMO model, they are not focused on the life cycle and they are not focused on acquisition per se, but we saw that we should be able to use this, but because this is a typical life cycle, or I would say project life cycle for a regular acquisition project. It ends when you do a transition from the procurement organization to the end user. So we also saw that we also want to have an estimate on the costing side. So we added the costing aspects, total cost of ownership to this. And we thought, can we use this to provide us evidence and input to our own judgment? And I can say already that I think we can. And when we thought about using COSYSMO for public acquisition, we saw that there are plenty of material already available. Amongst other things, it's publicly available, this COSYSMO model, where you can actually download spreadsheets and then put the data in the spreadsheets and get the result in engineering month. So it predicts the effort of conducting the technical part of a project. So that's what we were interested in getting insight in, and also comparing different bids. So what we saw, what we needed to do is that in a regular process, which includes acquisition, you're not doing the complete systems engineering tasks yourself. The customer doing something, our customer, we as a procurement organization are doing basic systems engineering when we define the system requirements. And of course, the supplier, the contractor, are doing the majority of the things. So we need to align the work share. And you can see that in a summary at the end, how we just predicted how that was supposed to be managed. And of course, when we do this, we can't just send out this as a questionnaire and ask the bidders, can you please provide us with data? We need to get the data in a proper shape and form, in a controlled way, so we fulfill the public acquisition laws which are applicable. And also something we liked was that this open method, it helps us in the future, because we can apply the calibration factors. We can apply that, okay, this was the idea when we wrote the contract, then at the end of the process with that customer, with that contractor, we can absolutely start to calibrate our own algorithm, so we can get better and better results based on the factors we have in the method. And by asking the bidders to provide us with data, we can absolutely make it possible for us to compare different things between the bidders. That helped us a lot when it come to technical and project type risk management. And a few words about the size drivers, which is the one of the parts of the COSYSMO model, is that you are supposed to think on your requirements entering the model. Are they easy, nominal, or difficult to manage and handle? And what we did was that we had a workshop where we selected 28 different metrics, and we adjusted them towards what we thought was a good baseline. And those were of the type correctness. Many of them were looking into semantic weaknesses, where actually I can mean something and the bidder can interpret it as something else. The more that was the case, the more it tends to be difficult requirements to work with. And we also looked a little bit into completeness and consistency, which are the two other aspects of the guide to right requirements, but not that much, because we can't really look into the future, into the solution. But again, we were not so much focused on getting a 100% accurate process. We want to have a controlled process where we can start to compare the input provided by the different bidders. But before that, the output from measuring the quality by using, in this case, our own tool, was that we got a very much standardized way of assessing the one of the biggest important parameters in the COSYSMO model. So I'm saying that if you're going to do this in a very efficient way, it's too hard to assess a set of multiple requirements if they are easy, nominal, or difficult. You need help, okay? And our tool just do that for you. And that's not all, because if you're writing requirements and you're asking a bidder to say, please state compliance, and they say, oh, yeah, I will fulfill all your requirements, they don't have to provide evidence that they have been doing this before. They are just providing a clear statement that they are willing to undertake the contract, and they are promising that by the day of the system verification that the requirement and design will be 100% complete and it will fulfill the requirements. So how mature are their proposed solution? So we said that, well, we want to align the technology readiness levels with the requirements statements as such, so that not only the bidders are set to write, are you compliant or not to a requirement, but how mature is your proposed solution towards the requirements we are stating in the request for quotation. And we also added the capability maturity model to the statement of work, the VBS parts, where again the different bidders had to look into their previous knowledge and experience on the delivery on and working in a system engineering way, so that we could see, do you have any documentation proving that you have control processes for different things, for instance, configuration management, project management, and so on and so forth. And we modified the COSYSMO effort multipliers according to the input that we received from the different bidders. And what we did was that these risk parameters were assessed a little bit on the side, besides doing a traditional evaluation of how compliant you are towards the fulfilling the requirements and the cost, because we didn't really know what to expect from this, but the outcome was much better than we thought in the first place. And for those of you that who are not that experienced with technology readiness levels, what we were interested in finding out was that even if you are a bidder and you're saying that you are 100% compliant to all our technical requirements, have you done this before or not? Okay, or sorry, have you done this before or not? So if you have a low TRL, means that you are unfamiliar to different types of requirements, or I would say different areas of the technology itself. So it means that you have a higher effort. You should have a higher effort in reaching those requirements, compared to if you have done this before and you even have a ready system or a ready solution that fulfills the needs, and it's already out there with other customers. So it should be much more predictable, and it should then lead to lower effort and lower cost. And the CMMI, it works a little bit in the same way, but you're then looking more into the process side. And those of you that knows traditional statement of work or work breakdown structure, you can see that most of the technical aspects of performing development can be covered towards the majority of the different system engineering work methods. So by asking the bidders how mature and have you controlled processes for a different set of the technical processes in 15288, we can say, have you done this type of work before? Or sorry, again, have you done this before, or are you a beginner? You don't even have a process for project management, for instance. Of course, it's more potential that you're doing the wrong things, the more potential that you're working with the wrong things, making presumptions about the requirements. You will have more integration problems because you don't have a control process. So it will be a higher effort. So it's not rocket science, but you have to control the input and make a controlled set of judgments from the data you receive. And just again, what we would also like to look into here is the costing side. Even if we are not putting any costing into the model itself, we at this point in time were interested in seeing, okay, what is the system engineering effort and the project cost compared to the operational and support and disposal costs. So we could say, okay, are you actually gaining funds in the operational phases for support rather than put them where they are supposed to be as part of development, just to improve the visibility and the possibility for us to check the data we received at the end of the day when we compared different efforts towards the costing they also provided us. So you will see some evaluation examples from this short pilot project where we actually developed a response where we aligned the different requirements in an evaluation matrix where the grades were weighed. They were not equally important. Some areas were more important than others, so it got more grades for that. And that was linked to a selected set of requirements. And that's something you are doing within the acquisition studio tool, where you link these things together. So you get a bundle of requirements to put scores against. We included, as I said, the TRL and CMMI and the requirement quality analysis as part of this process, this bid evaluation process. And we used standardized Excel templates, okay? And for those of you that thinks that no, you can't use Excel templates because you lose track of the data, I can reassure you that the Excel templates are just used for an easy way for the different bidders to enter data. The data itself is export and import in the database or requirement management tools, so we have full configuration management control of the data. But it's a very efficient way because everyone has Excel, okay? And you don't need a specific tools or training to answer the Excel sheet. So when we got the data back and we put it in the database, we could absolutely say that we are supporting the subjectivity on these things, or I would say that we are not supporting it, we are managing the subjectivity, so we get an objective selection of the bids, okay? And at the end, we summarize things and we provide data. In this example, you will see that we provide data where the score is calculated in a graded way. You can of course apply whatever evaluation model you would like. If you want to show it in as money or cost, or if you want to show it as in this case as data as such. And when you have set up these things, you don't have to redo it every time. So the data you receive, you can take that with you when you write hopefully a very good contract with the best of the bidders. So you can continue working with the data, for instance, looking into the costing side, or the data you have, which are part of the contract, which is supposed to be part of the system verification. You have everything in a very controlled way. So you are managing also the requirement side of this project, not just the costing, evaluation, and contracting side. And this is examples with just a simple screenshots from our engineering studio. This is some quick views on the different aspects we were looking into from the guide to write requirements with the different rule sets we have from INCOSE. So of course we are finding things, but the good thing with the system where it applies a high, medium, or low, it's very easy to understand that high is easy, medium is nominal, low is difficult to manage. And if you think a little bit about this process, this is actually a calculation on our own set of requirements. These are the requirements, the system requirements, which are part of the technical specification that goes out as part of the bid material. So we're analyzing ourselves. How hard are these requirements to understand by a bidder? And this forms input to the size estimates, okay? And all of the things which are part of the size evaluation is actually done by ourselves. We know, as I said, we know the interfaces, the proposed interfaces. We know about the applications. We know about the hardship to get an operational system, because we have done systems engineering when we developed this. So we are filling in those parts ourselves. It has nothing to do with the bidder. The other thing is just to show you the different evaluation examples where we can say that this is the how it looks like for a bidder. And this is the bidder CMMI self-assessment reports. What this is a very controlled Excel sheet. The red parts and the gray parts are nothing you can tamper with or edit. And you get an input that you're supposed to say, how good are you at project planning? Okay, I think I'm a level 3. Okay, please provide evidence that, and you can provide evidence with a process definition or whatever, so that we can make an assessment. Are you level 3 when it comes to maturity on project planning? And the same goes for the technical part, where the gray areas symbolize things which are locked. You are not supposed to tamper with them. And as I said, we added TRL as a separate parts. We can already see that they have stated things. They have said they are compliant, and they are now supposed to say, okay, compared to this requirement, how well are you prepared for this? Okay, then, and they say, oh, I'm in the prototype stage, we need to do some work. Okay, that provide us with input to the COSYSMO part. And of course, we had other sheets for the project, the statement of work, the pricing and such, and everything is managed in this database format. And if you're more interested in how these sheets work and how you set them up, I can propose that you listen to my colleague Lars and his presentation on a systems engineering approach to acquisition. And you can reach that previous webinar on our website in this following this link. But at the end, when we get all of these results, we do the math, we do the expert judgment, and we set scores on the different requirements or set of requirements. We end up with data. And just to have a visibility, we just provided it in Excel as well, but it can be provided in other shapes and forms. But here you can see it's different steps. But it's also different bidders. It's bidder 3 and bidder 13, and we can start to say which is better than the other one. Okay, and when it comes to CMMI, bidder 3 is not so good compared to bidder 13. And this is regarding a different scale. You can have 1 to 10 or 1 to 5 or whatever, based on the control process you have. But at the end of the day, when you add things up against the evaluation model you have, you end up to, you can say then that in this case, bidder 3 had 8.96 in score, and bidder 13 had 9.399. So this one is in a total better solution. It had a better score on risk, and it had a better score on the technical capability side, while bidder 13 had a lower price. And this means that we are doing this as objective as we can. The subjective part is when the subject matter experts has to put scores against the evidence they get from the different bidders on the proposed solutions. And when the bidders is saying that, yeah, I will fulfill your requirements, and this is an example on how I will do, then the expert evaluation needs to think, okay, do I believe this? Is this a good solution or a good idea or not? And provide their written statements also in this tool about that. That's the only subjective part you have. And then at the end of the day, when we took all the data, because this is the data that provides you evidence that we should choose bidder 13 before bidder 3. And this was actually at the final step. So you can imagine that we had more than 13 bidders, and it was only bidder 3 and 13 left at the end. So we did a down select there. So we then populated also at some point in time, every bidder got their own COSYSMO sheet. So we could start to put in the effort side. So when we populated this size parameters, which were our own work, with the data we received on technology risk and the CMMI, we actually could convert then the effort to system engineering cost. And this part, you can't probably see it. This is where we did the judgment, how much work is the supplier going to do and how much work have we already done compared to the system engineering activities. So we basically just did a judgment. Is it 10, 25, 50, 75 or 90% of the total work when it comes to technical management in the concept phase is done? And we just did a subtraction of the effort side to end up with a judgment which were more correct. But again, this was not done per bidder. This was done as part of the process. So this is static values. So the only thing which we added in this is actually these, when we aligned these metrics. Everything else was static. Well, perhaps not the costing side. I can't remember if we asked for man-hour rates for the different bidders, or if that also was static. I can't remember. But at the end of the day, we got a rather true effort when it compared to cost, because the model itself says it's plus minus 30% on the effort. And when we compared our own estimates of the cost with the proposed cost by the bidder, we were fairly close. We were absolutely within plus minus 20%, and we haven't done any calibration now. We just did these things. So it was quite interesting to see that we actually could use the model. So the takeaway from this very brief and short pilot project, it lasted for 6 months during that period in the bid and contracting phase, is that we do think that we could continue working with COSYSMO as a model for our own benefit, so we can start to have a kind of a parallel judgment mechanism to see, is the pricing fair? When we compare the price to their own estimates and what they put in capability model and technology readiness, what can we see there? And we saw a lot of things which we, if you don't understand the question, perhaps you raise the price very much because you put a lot of risk in it, or if you are immature in some areas, you perhaps underestimate the effort needed. And we saw in instances of that as well. They were too cheap, if you can understand that. So we think it can actually provide us a lot of input in the process of evaluating and negotiating with bidders. So it can be a good benchmarking tool, I would say. And combining it with other known techniques as technology readiness levels, where we put that against the different requirements, capability, where you have to put in self estimates and also proof of evidence that you actually are mature in different system areas. And of course, by introducing a very controlled way of estimating our own information quality in our requirements, that really introduced predictable estimate into the size drivers of this project. So we liked the idea that the model itself became very much evidence-based. We could track everything we put into the COSYSMO, and that was of course of great value to us. And we also, as I said, we also added the total cost of ownership or life cycle cost estimates so that we could evaluate if the bidders themselves try to hide cost by putting them later on in the system life cycle. So I think that we absolutely can. I will strongly suggest or hope that somebody will continue this work with newer and enhanced methods, for instance, using more artificial intelligence and where we could crunch a lot of data to introduce a better calibration mechanisms when we run projects and so on and so forth. This method itself is providing us a lot of nice possibilities for input and improving the results. And this was presented in Canada in July by myself, and you can reach me in this address, or you can contact the head office in Madrid in Spain, or my colleague Hubertus in the America. So by that, I'm actually going to hand over for the question side of this, and I can see that there are actually questions. First question: does COSYSMO also provide tools to build a request for quotation? That's a good question. The COSYSMO model as such is just an algorithm, but the acquisition tool, part of systems engineering suite, it will provide you with the possibility to build specifications and also to print them in a legal form in paper, meaning that you are building specifications out of a system engineering suite and acquisition studio. And if you're interested in more, please look into my colleague Lars and his presentation in the previous webinar. Okay, I have a question about make and buy decisions. Are they made by this tool? Make and buy decisions are part of the system engineering effort itself. So when we do the system engineering part of this, we need to be able to assess if we're going to build things ourselves, meaning that they will be part of the acquisition, or if we should buy something ready out of off the shelf. And this process, of course, can help you in judging that things, but it's not the key aspects of the acquisition studio as a tool, but used later on with the COSYSMO model, it can absolutely be of help. Absolutely. Another question: how hard would it be to run COSYSMO analysis on my project? Well, it won't be hard, but you need to have data with some kind of quality. And if you mean your project is an acquisition project, you need to be able to put in multiple data sets, because you have different data sets for different bidders. But you can also run, of course, COSYSMO on your own development project. It's just managing the data. Then of course it would be an improvement to measure the true requirements quality to assess if your requirements are easy or even hard to implement. And the last question I have here is: has this been used in actual projects, and what was the result? Yeah, and I hope that I explained that so clearly that the key takeaways here is that yes, we worked in a small pilot project, and it provided us with a lot of self-evidence that we had chosen the right bidder, or we got a lot of information that we used during negotiations with the different possible bidders. So it was a good parallel track that gave us a lot of information. And I think that was the last question. If there aren't any more, I would say that thank you very much for listening in to this webinar. You can always contact us, as I said before, and hope to see you soon in another webinar. So thank you very much and goodbye.